All right, welcome back, class. This is 8.2a, composition of functions. And in this lesson, we will be able to perform operations with power functions, and we can state the domain on power functions. So, when we get right into it, we have two functions here, f of x equals 2x and g of x equals 5x minus 1. So this right here, f of g of x, is the composition of the functions. So when it asks us to take the composition of f of g of x, we have to plug in g of x where x goes in our function. So g of x is this entire function here. So we must plug that in for our x value. So f of g of x equals 2 times 5x minus 1, because we plugged in the function g of x in for x. So then we can simplify that. We can distribute our 2 through, so then it becomes 10x minus 2. And from there we can list our domain. So in this case, there are no restrictions on x for f of g of x. So our domain is going to be x is an element of all real numbers. Next, we're going to do it the other way. So now we're going to do g of f of x. So let me get rid of some of this. Now we need to plug in f of x for our x value and g of x. So this is f of x. So we now must go the other way. This must be plugged in for our x value that way. So g of f of x is written as 5 times 2x minus 1. So now we have a product, so we can multiply that. So we have 10x minus 1. And once again, there's no restrictions on our x value. If we were to graph this function, all real values for x would be shown on the graph. It's linear. So we can label that as all real numbers. Now we can take the composition of f of x with f of x. So we're plugging in f of x into our f of x. So to be clear, the function f of x is 2x. And we need to plug in f of x for our x value. So when we plug that in, that becomes 2 times 2x, because we plugged in 2x in for x. So then we can simplify that, and that just simplifies to 4x when we multiply that. And again, our domain is all real numbers. So now we can do it for power functions. So let f of x equals 2x to the third power and g of x equals x to the 3/4 power. So f of g of x, again, we're going to be plugging in now g of x for x in this function. So that's going to be 2 times x to the 3/4 to the third power. So we have a power to a power. So when we have a power to a power, we can multiply that. So that becomes 3/12 for our exponent, and we can simplify that to 2x to the 4th, because 3/12 reduces to a 4th. And we can rewrite that in our radical form. So 2 times the 4th root of x. Now we will have a restriction. So to be clear, when we have an even index, just like we went over last week in class, we cannot have a negative radicand, because then that will be imaginary and not real. So for our real values, our domain, we want real values for x. That will be from 0 to x to infinity. X is strictly greater than or equal to 0. Because if you plug in a negative value, then you'll get an imaginary number with an even index. So just like last week, even index, we need positive values for real numbers under the radical. So now let's do g of f of x. So g of f of x, we're now plugging in 2x to the third power in for x. So 2x, to the third, and we raise that to the 3/4 power. So yet again, at this step, they are the same, because when we take the power, or excuse me, actually, we have a product raised to a power, so we need to distribute that 3/4 through. So we have 2 to the 3/4 times x to the, well, that would have simplified to the 4th. So then we have the 4th root of 2 cubed, so that'd be 8, times x to the 4th, which then becomes the 4th root of x. We now can combine, because our root or our indexes are the same, so we can multiply the inside, so that becomes the 4th root of 8x. So from here, we have an even index again. So we will have restrictions where values cannot be negative. So yet again, it's 0 is less than or equal to x, which is less than infinity. If you plug in a negative value for x, anything negative times a positive will be negative. So it's restricted to greater than or equal to 0. Now let's do f of x. So for x, we're plugging in f of x, which is 2x to the third, and we're raising that to the third power. So first here, we're going to want, because we have a product raised to a power, distribute that. So we have 2 times 2 to the third times, well, it would be x to the 9th. So then we can simplify that. 2 times the cubed root of 2 times the 9th root of x. Now for this case, we have an odd index. So because our index is odd, we can have negative values. So now here we can have all real numbers. Finally, one more group of examples where we need to take the composition. So we have f of g of x. So before we do that, let's simplify this. So since we have a negative exponent, we can simplify by doing the reciprocal. So f of x also equals 2 over x. I did the reciprocal, so I simplified it to 2 over x. Now when we do the composition with g of x, we plug in x squared minus 1 for x. So x squared minus 1 got plugged in for x. So we have a difference of perfect squares, so that will simplify to x plus 1 and x minus 1. So we have restrictions in the denominator. When we have x values in the denominator, just like back in Unit 6, that they will be restricted values. So those restrictions are going to be when we have 0 in the denominator. So if we set both of those equal to 0, so I'm going to do x plus 1 equals 0 and x minus 1 equals 0. X cannot equal negative 1, nor can x equal a positive 1. So these are the restrictions. Cannot equal. Besides those values, it is all real numbers except for the restrictions. So now let's do g of f of x. Now we're plugging in f of x into our x value over here. So that is 2 over x squared minus 1. So it's a quotient to a power, so we must distribute. So that becomes 4 over x squared minus 1. And in this case, we can set x squared for our restrictions. So I'm going to do it down here. Restrictions. X squared, because it's in the denominator, cannot equal 0. So if we were to do our operations, x cannot equal 0 for this problem. And besides that, the domain will be all real numbers, besides our restriction. And then we can compose f of x. So f of x is 2 over x. So then we must plug in 2 over x for x. Since we have a fraction in the fraction, we'll want to take the reciprocal. So that becomes 2 times x over 2, which then our 2's will simplify to 1, so we are left with x. So in this case, we have no restrictions. f of x equals x. So in this problem, there are no restrictions, so the domain is all real numbers. All right, thanks for listening. Let me know if you have any questions and email me with those. Okay, thanks. Bye.